The theory of everything has been found. Hello, my name is Harris Sarantopoulos, and I have found the theory of everything. This is part 3 of the theory of everything. If you haven't seen part 1 and 2, you should see them first. In part 3, I'll talk about the connection model, a model that connects all the fundamental forces and tells us what protons and neutrons are made of, and a very important constant that we should be using. I described earlier that the universe is a three-dimensional field structure that is constructed by lines of mass. The universe is not just one field, but 3 fields coexisting as one field. Each field is a three-dimensional grid, so the field lines of each field pass between some of the lines of the other 2 fields. The first field has lines that are 90 degrees to each other. The other 2 fields have lines that lie at 45 degrees to the first field. When the field is compressed to form particles, the force of compression comes from all sides. A single field with lines at 90 degrees to each other would allow quantum particles to escape at right angles to the direction of force. Lines at 45-degree angles prevent this from happening. Each field can be distinguished by the distance their parallel lines are to each other. The first field has the shortest distance and the greater number of lines. The second field has wider distance and less lines, and the third field even wider and less lines. Each field is responsible for one of the 3 fundamental forces of the universe: gravity, the electric force, and the magnetic force. They also each produce a particle, the electron, the photon, and the neutrino. We have already seen the mechanism for force that holds particles together. The strong and the weak nuclear force does not exist. When I explain how protons and neutrons are made, and the role of the neutron in the nucleus, we will see why these extra forces don't exist. To understand the fundamental forces, we need to understand the significance of the distance between the lines in each field. When the field is compressed, the lines are pushed closer. This creates a greater energy and a force that is inverse to distance. Each distance governs one of the fundamental forces. The distance between the lines of the first field is 1.334 times 10 to minus 10 meters. To create a particle, you need force from opposing sides to push the field together. This will bring opposing lines halfway to meet at the middle. This distance is 6.67 times 10 to minus 11 meters and becomes the gravitational constant. Electrons are created by this field, but not the electric and magnetic components of the electron. This field is also responsible for gravity. The next field is responsible for the electric force. My theory introduces a new constant for the electric force. I refer to it as the electric field constant. Physicists call the vacuum electric permittivity the electric constant, but in reality this is an electron current field, and I will discuss that later. To arrive at this constant, we divide the speed of light by the square of the speed of light. This gives us 3.3 times 10 to the power of minus 9 meters. When this field is compressed, opposing lines will also be pushed halfway to 1.6 times 10 to minus 9 meters. Now, this number is already known in physics. Its general relativity is 8 times pi times g. What also happens when the electric field lines are compressed is the creation of the photon. The last field is responsible for the magnetic force. These lines are even wider apart at 1 times 10 to the power of minus 7 meters. When they are compressed, they create the neutrino. The electron and its properties are formed by the compression of all three fields onto a central mass of quantum particles. The first field, 1.3 times 10 to the power of minus 10 meters, is compressed by a lateral distance to 1.67 times 10 to minus 11. The compression creates a central mass with a radius. The field can only be compressed by the value of the speed of light. The radius comes from 6.67 times 10 to minus 11 divided by the speed of light. This equals 2.2 times 10 to minus 19 meters. When the field lines are pushed together, the force created is the square of the speed of light. This is the force that holds the electron together. The electric field lines are also compressed onto the electron radius. This gives the electron a larger radius because there are now more lines on it. We divide 3.3 times 10 to the power of minus 9 meters by the Coulomb constant, 8.9 times 10 to the power of 9, and we get 3.7 times 10 to the power of minus 19 meters. So why use Ke? As I said before, the square of the speed of light is a force. Ke is the electric force. The compression of the electric field lines to the electron radius creates Ke. This gives the electron its electric field. The magnetic lines are also pushed towards the electron radius. However, they don't go all the way. This is due to the funneling effect. In part 1 I showed how the lines stay attached to a particle by the funneling effect. Quantum particles are funneled onto the radius, which creates a higher level of energy in that area. The quantum particles bouncing off the radius will encounter the magnetic lines, and this prevents the magnetic lines from getting to the radius. By how far are the magnetic lines pulled towards the radius? We divide 1 times 10 to the power of minus 7 meters, the magnetic constant, by Ke, and we get 1.1 times 10 to the power of minus 17 meters. Hypothetically, if the electron could be at rest with the field, it would be a monopole. There would be no positive side. It would be all negative. What prevents a monopole state is simply moving through the field. A moving electron becomes a dipole. Velocity changes the electron's field. It reduces in length in the direction it's traveling in. So the electron's field is subjected to length contraction. This contraction narrows the electric and magnetic fields and alters their shape. More field lines are pushed onto the electron on the side that it's moving in. This creates a positive force. The electric and magnetic fields at the rear of the electron are not pulled in, so that side remains negative. As the electron moves, all three of its fields are reduced in the direction of travel. The reduction in the field is measured this way. ER, the electron radius, times c squared divided by velocity squared. The majority of the mass comes from the first field, the mass gravity field, and the electric field adds to its mass. When the electron is created, the electric field lines are pushed onto the gravitational constant field, 6.67 times 10 to minus 11. This gives it a slightly larger number, 7.35 times 10 to minus 11. This is then divided by Ke squared, which gives us 9.1 times 10 to minus 31 kilograms. Ke 8.9 times 10 to the power of 9 is a force. We have seen that the speed of light squared is a force, and the square root of that is a speed, the speed of light. So the square root of Ke is a speed 94802 meters per second. If we divide 94802 by the speed of light squared, we get 1.05 times 10 to minus 12 meters. If we also divide 1.05 times 10 to minus 12 by 94802, we get 1 times 10 to minus 7 meters, which should be the proper magnetic constant. So both the electric and magnetic forces are powered by Ke. It's just that there are more electric field lines, so the electric force is more powerful. When the electron is created, the magnetic field lines are pushed towards the electron radius. When the lines have a distance between them of 1.05 times 10 to minus 12 meters, there is more energy between the magnetic field lines. So when this passes over an electron, it pushes the electron into a shape that gives it positive and negative sides. However, this does not cause the electron to flow. So electrons in a wire, for example, are not moving along the wire. The change in the electron forms the electric field of the electron into a positive and negative field. If the magnetic field stops moving over the electron, then the forward resistance on the electron pushes its shape back. So there is now no positive and negative electric field. The faster the magnetic field moves over the electron, the greater the electric field is. I showed you this equation before. ER, the electron radius, times c squared divided by velocity squared. The square of the velocity is a force. So if we substitute velocity for Ke, we get EO, or something close to it. So why aren't we getting exactly 1.05 times 10 to minus 12? It could be that the three fields reduce each other's lengths. So if we do it this way, 1.05 times 10 to minus 12 times Ke, we get 0.0094802. If we divide that by the square root of Ke, we get the magnetic constant, Km, 1 times 10 to minus 7. Our universe was formed by a collision of two separate fields that compressed the field lines together and created electrons, positrons, photons, and neutrinos. All of these particles are created close to each other in a system called a positronium. Physicists believe that the positronium is the antiparticle of the electron, and if they meet, they will annihilate each other. But what is really happening? First, what exactly is a positron? Positrons are the positive version of the electron. It is an electron with two photons, one on each side. The universe creates particles in pairs, so it will create two electrons at the same time, but one of them will have two photons created close to it. If we divide my magnetic constant, 1 times 10 to the power of minus 7 meters, by Ke, we get 1.1 times 10 to the power of 17 meters. This is where the photon is created. We use the magnetic constant because light has a magnetic and electric component. Electrons and photons are negative. At creation, they repel each other. Because the electron has the greater mass, the photons are pushed away. However, they do not get very far. As they are pushed away into the field, they are pushing the field lines in front of them closer together. This creates energy in front of the photon, preventing it from moving too far away. Between the electron and the photon, the field lines are wider apart. This would allow for negative energy and the photon to be pushed back to the electron. However, what prevents this is the funneling effect that I spoke about in part 1. In that area, there is a high volume of quantaparticles supporting the photon. So the photon creates what would be described as a larger radius for the electron, overcoming the negative field of the electron. So the positive force pushing the photon back to the electron is equal to the repulsive force between the photon and the electron. So the photon is locked into a static position. This now becomes a static positive force. As this happens on both sides of the electron, the positron is balanced and it becomes a positive particle, however positive only to another electron. Positrons are not antimatter. There is no such thing as antimatter. So how do electrons and positrons annihilate each other? It comes down to the orientation they have to each other at the time they are created. The positron is an electron with two photons, one on each side. So it is only positive in one alignment. If we call that the x-axis, then the y-axis is not positive. And this is where the positron and electron face each other. So now you think because there are two electrons facing each other, they would repel. However, because they are created close together, there is a negative area between them. This means that the field lines between them are wider apart. So each particle is able to pull lines away from each other. Eventually, the lack of field lines can no longer contain the mass of quantaparticles that make the electrons, and there is a burst of energy which repels the two photons away. However, this process can be disrupted by free photons impacting the positronium, causing the two to separate before annihilation. A source of free photons at the time the universe formed would be the parapositronium. Some electrons and positrons would therefore be prevented from disappearing. So there is an equal amount of positrons and electrons shortly after the universe started. As there is now a sea of electrons and positrons in the universe, the conditions would be right for currents of electrons and positrons to form. When these currents collide head-on, the next particle is created. The proton is made from one electron in the middle with two positrons, one on each side. In physics, there is a problem called the matter-antimatter asymmetry problem. In the fairy tale theory, that is the Big Bang theory, equal amounts of matter and antimatter should have been produced. Physicists don't know what happened to the antimatter. There is no such thing as antimatter, and what they consider antimatter is the positron. So the so-called antimatter is locked up in protons and neutrons. Two positrons went into making the proton and only one electron, leaving more matter than so-called antimatter. A simple hydrogen atom will therefore have two positrons in its proton, with one electron and another electron bound to it. Therefore, there is equal amounts of matter and so-called antimatter. Electrons and positrons in the early universe would collide and be compressed to form protons. In part 1, I talked about how a positive and negative particle weakens the energy between them, and therefore creates more energy on their opposing sides that pushes them together. This is what happens with the electron and positron. The strong nuclear force that is supposed to hold quarks together doesn't exist. It's just something physicists made up because they don't know any better. For that matter, I'm not even going to talk about quarks. They don't exist, and it would be a waste of time. The proton exists within a negative field as all particles do. Its radius has been extended far beyond the electron radius, creating a positive force within a negative field. But this positive force is only positive to an electron. The proton radius must sit at a critical energy level. The force pushing in from the outside must be equal to the force pushing out. The configuration of the proton is an alignment of positrons and an electron. So this pushes the electric and magnetic field lines back to a distance where there is an equal force inside and outside on the proton. The proton, just like the positron, is positive in one alignment. With the y-axis, there is still some negative field because of the electrons in it. If another proton was to align in the y-axis, they would annihilate each other. So antiprotons are just protons. The mass of the proton, like its radius, sits at a critical level. Too much mass and it cannot be contained. The process in which the proton is formed is by collision and compression of the field lines. So the field will be compressed to a size less than that of the radius and then pushed back to the radius. Only a small amount of mass is contributed by the one electron and two positrons. The rest of the mass comes from the energy that existed in the field when the field was compressed. So the field will be compressed from my magnetic constant, 1 times 10 to the power of minus 7, to the proton radius. If we divide my Km by Ke squared, we get 1.2 times 10 to the power of minus 27 kg, less than the proton mass. The mass gravity field, 2 times g, 1.3 times 10 to the power of minus 10, is also compressed. Divide this by c squared, we get something close to the proton mass, 1.4 times 10 to the power of minus 27 kg. The point to these numbers is that each field is pointing to a critical mass, the maximum mass the lines can contain, and that each field is contributing to the proton mass. The neutron is a proton with a neutrino and an extra electron that gives it a larger radius and mass. A free neutron will decay to a proton because its internal forces due to these extra particles are greater than the forces pushing on it from the outside, so it decays to a balanced particle, the proton. The neutron exists in a negative field, and its radius, just like the protons, is projected into the negative field. However, its radius is slightly greater than the protons. Its radius pushes the distorted field back, so the field around the neutron is less distorted. This reduces the negative field and it becomes neutral to protons, electrons, and the electric field. So there is no connection with the electric constant, but the neutron is affected by the magnetic field. If we multiply the neutron radius by Ke, we get 9.8 times 10 to the power of minus 6, 0.01 away from my Km, 1 times 10 to the power of minus 7. I showed in part 1 how positive and negative particles attract each other by weakening the field between them and therefore allowing more energy on their opposite sides, which pushes them together. The problem with this is that the proton and electron would collide, but they don't, and this is why they don't. What prevents them from colliding is that as the electron approaches, it begins to build up energy in front of it by pushing field lines closer together. This eventually creates enough energy to repel the electron back in the reverse direction. As it moves away, it builds up energy and is repelled back towards the proton. So this becomes a harmonic oscillator, oscillating towards and away from the proton. The electron is therefore not orbiting the proton. The reduction of energy between the two increases energy on the opposite side of the proton. This effectively increases the proton's radius on that side and usually prevents the attraction of other electrons, as the proton's electric force is pushed to a more neutral level. I gave a description of how virtual photons are created in part 1. As the electron moves towards the proton, it's building energy in front of it in the form of a virtual photon, and this energy repels it the opposite direction. However, this also pushes on the proton slightly, repelling the proton. Therefore, we have a vibrating proton. As the electron is pushed away from the proton, it's pushing field lines in front of it closer together, creating the virtual photon. It is this oscillation that creates the hydrogen spectral lines. What prevents protons repelling each other in the nucleus is the neutron. The neutron acts as a buffer between two protons, and this happens because of a known phenomena, the Casimir effect. So how does this happen? The key thing is the vibrating proton due to the oscillation of the electron. First, how does the Casimir effect really work? The most common example is with two uncharged conductive plates placed a few nanometers apart. An attractive force arises and the plates move together. So what really happens is a little like what happens between the proton and the electron, in that the field between them is reduced in energy, creating more energy on their opposite sides. However, with the Casimir effect, both opposite sides are equal in strength. So between the two plates, the field is not as distorted, so the plates are pushed together. The effect the oscillating electron has on the opposite side of the proton is similar to a tidal effect. Energy between the two is reduced. The opposite side of the proton radius increases because more lines are pulled onto it, so its mass and its radius increase. The proton's radius increases to match the radius of the neutral neutron. So now between the proton and the neutron, the field is more neutral with less energy, so they are pushed together from opposing sides. A proton can fit on the other side of the neutron, so the neutron becomes a buffer between protons, stopping them from repelling. The range of the supposed fictional strong force is between 1 to 3 times 10 to the power of minus 15. This is around the same as 2 times the neutron radius, the neutron diameter, 2.2 times 10 to the power of minus 15 meters. With general relativity, I'm talking about Einstein's gravitational constant, 8 times pi times g divided by c to the fourth. But only the 8 times pi times g part. If we do 8 times pi, it equals 25.13. Then multiply g, 6.67 to minus 11, we get 1.67 times 10 to minus 9 meters, half of my electric constant, 3.3 times 10 to minus 9 meters. Now let's take the time dilation equation from special relativity and reform it in this way, using 8 times pi times g. We find that either formation will come to the same result. This is showing a connection between the mathematics of special relativity, general relativity, and a physical distance. Why does 8 times pi times g, or half of my electric field constant, coincide with time, length, and distance? The electric and magnetic field lines sit at an angle to the mass gravity field. This forces movements in the field to be in a wave motion. It's this wave motion that increases the distance an object travels, and that correlates with a slower time. Well, that's the end of part 3. In part 4, cosmology, we will see how the universe really started. Not with a big bang, but with a big collision. We're going to see why stars in galaxies rotate the way they do, and it's not dark matter, because there's no such thing as dark matter. I'm going to tell you about something more dangerous than black holes, pockets in the universe where there is no universe. I'm also going to tell you about how at one point we had an expanding and a static universe at the same time, and lots more.